Hello everyone. Today we will review Unit 8. Unit 8, 8.1, measuring the rate of reaction. Firstly, we should know what do you mean by the rate of reaction. If we want to give a simple definition for the rate of reaction, we will say rate of reaction is how fast or slow the reaction is. Then, any chemical reaction or in any chemical reaction, what we will have reactants and products. What do you mean by reactants and products is, for example, if you will say uh, carbon plus oxygen, okay, equal to carbon monoxide. Now, what do you mean by this? This part, this side, we call them reactants, while the compound or the substances here, we call them products. Now, if we want to measure the rate of reaction, we will depend either on the amount of reactants that it react in specific time, or we will depend on the amount of products that has been made in a given time. Now, the rate at which a reaction takes place can be measured by working out this one. How much of one of the products has been made in a given time, or how much of the reactant is used up in a given time. So in this way, we can measure the rate of reaction, either by depending on the reactants, this part, this side of the formula, or depending on the amount of products that has been made. For example, when you add a piece of magnesium ribbon to hydrochloric acid, a hydrogen gas is given off. Now, if we will take a look on this example, and let's try to find which substance it's the reactant and which one it's the product. Here it says when you add a piece of magnesium ribbon to hydrochloric acid, a hydrogen gas is given off. So magnesium and hydrochloric acid are what are example of reactant, okay? And hydrogen gas, it's what? It's the product. Question. Write the word equation for the reaction of magnesium with hydrochloric acid. How to write this formula? Firstly, we have magnesium plus hydrochloric acid equal to, here, if you remember, here what do we have? We have metal with acid. If we have metal with acid, what we will get? We will get salt, which is magnesium chloride plus H, which is hydrogen. When a metal reacts with acid, we will have salt plus hydrogen. In this kind of reaction, okay, how you can measure how quickly the chemical reaction is, you will depend on what we said. It's either you will depend on the amount of reactants that it react, or the amount of products that has been made. So here, when you will do this chemical reaction, bubbles will start forming. Okay, so in this kind of reaction, you will depend on what, or to measure the rate or to find the rate of reaction here, you will depend on the amount of hydrogen gas that produced. Okay, so if you want, the easiest way is to measure how quickly the hydrogen gas is produced. What you will do, you can measure the volume of gas produced in a particular length of time. 8.2 changes in the rate of reaction. The rate of reaction, it will change. For example, if you measure the rate of reaction, you find that the rate changes as the reaction proceeds. For example, in a chemical reaction between calcium carbonate and hydrochloric acid, here what do we have? Acid plus carbonate. We will have carbon dioxide gas. It will be given off. When this chemical reaction it just start, lots of bubbles will be produced at the beginning or at the start of the reaction. As the reaction continues, fewer and fewer bubbles are produced. This shows that the reaction has slowed down. Here, if you look at this experiment, which it's mixing calcium carbonate with hydrochloric acid. Firstly, when you will mix both of them, you will put it on a balance. You will see here you have this reading. It gives the mass of both of the substances, the calcium carbonate and hydrochloric acid. But once the chemical reaction will start taking place, bubbles will start forming. These bubbles are the carbon dioxide. When this carbon dioxide bubbles, it goes up, so it will goes out of the container or this beaker. If the chemical reaction will continues, you will see the total mass of these substances will start decreasing. Okay, why it start decreasing? What happened? Because one of the substances, which is carbon dioxide, it's going outside. Now, how we can use the graph to show the rate of reaction? Here, this graph, it's this graph, it shows the mass of carbon dioxide produced during a specific period of time. Once the chemical reaction is start, we will see lots of bubbles, lots of carbon dioxide will be produced. But when the chemical reaction it continue, so what will happen? The number of bubbles or the amount of carbon dioxide produced, it will decrease, will be less. So explanation for this, the graph can be used to measure the rate of reaction at any given time. The slope or gradient, here what do you mean by slope or gradient? It's this line. Okay, the slope of this line, it tells you what? It tells you how quickly the reaction is taking place. The steeper the slope, the faster the reaction. Here, as you can see, if you will follow this line, okay, here it's steeper. Okay, the steeper the line is, or the slope is, the faster the reaction it is. So now if you will have this graph and a question, it says at which point the chemical reaction it was fast, and at which point it's slower, and when it stopped. So you will say at this point, okay, here it's fast, here it will be slower, and at this point, okay, it's the chemical reaction it stopped. Why? Maybe they will say, why here the why? What do you think? Why the chemical reaction here it stopped? Okay, or how do you know the chemical reaction it stopped? You will say because here is the line it stopped increasing. Okay. Why does the rate of reaction change? Any chemical reaction, or when we say two substances it react with each other, in fact what it's happening, the particles, okay, of these substances are hitting each other, or they are colliding with each other. Okay, for example, here it shows the green circles or the green dots, it shows or it represents the hydrochloric acid. The purple or the purple one, it shows the purple or blue, that it shows the calcium carbonate. As you can see what it's happening, for if you will focus on the arrows, it shows these particles at the start of the chemical reaction, they are a lot, so they are hitting each other. When they will hit each other, they will form a new substance. At the beginning, there are lots of hydrochloric acid particles and calcium carbonate particles. Okay, many particles and frequent collisions. Here it's at the beginning or at the start of the chemical reaction, but as much as the chemical reaction it continue, so what will happen, these particles, okay, fewer particles and less frequent collisions. So for a chemical reaction to take place, the particles of the reactants, here the reactants are hydrochloric acid and calcium carbonate, involved have to collide. Here you should focus on this word, have to collide, okay, with each other with enough energy to react together. At the start of the reaction, there are lots of particles that have not reacted, okay? So collisions happen frequently. The main idea of the rate of reaction and why it's fast at the beginning and then it's slow gradually, it's because of the number of collisions. Okay, at the beginning of chemical reaction there are lots of particles that are colliding with each other, so that's why the chemical reaction is fast at the beginning and then it will slow down. 8.3. 8.3, here we will see what are the factors that affect the rate of reaction, or what are the things that it makes the chemical reaction faster or slower. Firstly, the first factor is surface area. Surface area, as much as the surface area increase, the rate of reaction it will also increase. Okay, more surface area leads to faster or faster chemical reaction, faster reaction, or you can say higher rate of reaction. In another words, just when you have a question about how surface area it affect the chemical reaction or the rate of reaction, you will say the more surface area, the faster chemical reaction will be. But if you will have a question that it says explain why surface area, why more surface area, it leads to a faster chemical reaction. Let's take a look on this on this example. You have here bread. Okay. What do you think? If you will put this bread outside, which one will dry faster? If the bread is in this shape or in this shape as slices, okay? Of course, the answer will be the slices. But why the slices will dry faster? The explanation for this question is the slices have much greater total surface area than the whole loaf or bread. What's that mean? Here, the surface area, it means more atoms that it will react, okay? Firstly, here, only the atoms that are at the outer surface, okay, will, they are in a direct contact with air, okay? But here, no. Each one, here we will have more atoms in a direct contact with air. That's why the slices will dry faster. Here, another explanation. If you have a chemical reaction of magnesium with something else, okay, only the magnesium atoms on the surface can react with oxygen. Okay, in magnesium ribbon, more of the atoms are on the surface and can react with oxygen in the air. So more surface area, it means more atoms that will participate in the chemical reaction. Temperature and the rate of reaction. Temperature, also it's one of the factors that affect the rate of reaction. Temperature, as much as the temperature increase, the rate of reaction also it will increase. More temperature, faster rate of reaction. An example, let's say if you have sugar and you will put it in cold water, and in another cup also you have water, you will put sugar in it, but the water here will be hot. So what do you think, in which container or in which cup the sugar will dissolve faster? Of course, it will dissolve faster in the cup with hot water. Why? Because the temperature here is higher. So the higher the temperature is, the faster the reaction will be. Now we talked about surface area, more surface area, faster chemical reaction. Temperature, higher the temperature, the more or the faster the rate of reaction will be. Here, if you look at this graph it shows a volume of hydrogen produced in a chemical reaction. Okay, here it's when the temperature it was 30, and here when the temperature it was 40. See, if you will compare these two lines, okay, you will see when the temperature it was 40 or more temperature, the line it was steeper. Okay, so that means the chemical reaction here will be faster. Okay, now explanation for the temperature, or explanation why increasing in temperature it will increase the rate of chemical reaction. Firstly, temperature, it's heat, and heat, it's a form of energy. So when particles of substances will be given more heat, it means you are giving more energy for these particles. If these particles will gain or will have more temperature, more energy, that's mean will start moving faster. When these particles move faster, it means it will collide with each other faster or more. So what will happen? There will be more collisions. Focus on the word collision. The chemical reaction, it depends on the number of collisions per unit of time, or during a specific time. So particles move. Explanation, the effect of temperature. Particles move all the time. When the temperature of the reaction is increased, the particles move faster. When they will move faster, they collide more often with more energy. 8.5, concentration and the rate of reaction. Now, how the concentration of substances will affect the rate of reaction. Here, what we should know, what do you mean by concentration? Concentration, it means the amount of particles of matter in the matter. For example, you have two containers, and this, it has 4 particles, okay? And here we have another container. Here, this container, it contains 6 particles. Okay, now what do you think? Which one has the higher concentration, or concentration of which one of these two is more? Of course, this one will be more, okay? Why? Because it has more matter. Now, which one will participate, or when they will participate in a chemical reaction, what do you think? Which one will be faster? The rate of which chemical reaction will be faster? Also, the answer is this one. Why this one? Because the higher the concentration, the faster the rate of reaction will be. Explanation for this. Explaining the effect of concentration. Here, the green, it shows hydrochloric acid particles, and here we have marble particles. If you look at this marble particles, it's the same amount of marble, but the difference is what? The concentration of the acid. Here, as you can see, the concentration, it's more, okay? Why it's more? Because more particles, because there are more particles of the hydrochloric acid. Okay, now, which chemical reaction will be faster? Also this one. Why it will be this one more? Because more particles, it means more chance to collide. Okay, so there will be more collisions. More collisions, it means the chemical reaction will be faster. Again, we can use particle theory. What do you mean by particle theory? Particle theory, it means all matter are made up of particles. To explain how these results. The higher the concentration of hydrochloric acid, the more hydrochloric acid particles there are in a given amount of space. This means that there will be more frequent collisions between hydrochloric acid particles and calcium carbonate particles. So, as you can see, in all the explanations, we are talking about particle theory. We are talking about the amount or number of particles or amount of particles, and the more the particles will be, the more collisions will happen. When the number of collisions will be more, that's mean the chemical reaction here is faster. 8.6 catalysts. Catalysts. What do you mean by catalyst? It's any chemical substance that speeds up the chemical reaction without changing in its structure. Again, catalyst. What do you mean by catalyst? It's any chemical substance that speeds up the chemical reaction without changing in its structure. Okay, what do you mean by without changing in its structure? Here we are talking about the catalyst. When it will participate in the chemical reaction, it just makes the chemical reaction faster. Nothing will happen to the catalyst. Nothing will happen to the structure of the catalyst. Okay. Example of catalyst. For example, diet, okay, bleach, okay, all of these are examples of chemical reaction. For example, when if you are washing clothes and these clothes are dirty and it has some, let's say, oily spots, or let's say oily spots, okay, if you will wash it with water, maybe the oil will not go, okay, so it will not vanish. So what you need to do here, you need to use a substance that it helps removing this oil from the clothes. So what you will use, for example, you will use bleach, or you will use Tide, okay, or soap, okay. Tide, soap, bleach, these are examples of what? These are examples of catalysts, okay. So what they will do, they will speed up the reaction. What is the reaction here? It's removing the oil from the clothes, okay. Another example, it's enzymes. Enzymes, here we are talking about living things, about human, plants, animals, okay. Let's take example, enzymes in human. Enzymes, when you eat food, this food, when it goes to your digestive system, your digestive system will break down the food into simpler substances. Okay, breaking down food into simpler substances, this it's a chemical reaction. This chemical reaction without enzymes will takes a long time. So in our body we have biological catalysts, okay. The enzymes, they call them biological catalysts. The function of these enzymes is to what? It's to speed it will speed up the breaking down of food. So breaking down of food, for example, without enzymes, maybe it will take, like, let's say 2 or 3 hours, but with enzymes it will just take a couple of seconds. Okay, some questions. Question number 1. What is another name for a biological catalyst? We just highlighted here. Enzymes. Enzymes is the answer for question number 1. Okay. Question number 2. What sort of washing powder has a catalyst in it? Example, Tide. Question number 3. Why do cars have catalytic converters fitted to them? What do you mean by catalytic converter fitted in the car? It's the car exhaust. Car exhaust, the function of the car exhaust, it's what? It's to balance the chemical reaction in the engine. it makes the chemical reaction in the engine faster. Okay, so what will happen? It will balance between the consumption of fuel and also energy produced. So here, what's the function of it? It will do what? It will increase the rate of chemical reaction, increase the efficiency of the engine, and also it will balance the heat. It will keep the heat of the engine a little bit lower. So a summary for this: a catalyst, we said, it's a substance which speeds up a chemical reaction without changing in its structure. A catalyst is not changed in the reaction and can be recovered and reused. So this was everything for Unit 8. Your task is solving the end of unit questions. And again, don't forget, watch the video. When you will finish watching the video, write a comment below the video so I can make sure everyone here received the video and he got all the details of the video. Again, if you have any questions, concerns, please don't hesitate to text me. I will write my email and my phone number, so if you have any questions, please text me.